Next, we're going to talk about factoring trinomials where the leading coefficient does not equal 1, so where there's some number in front of our squared term. And there's a bunch of different ways to do this, starting by guess and check and going on to the universal method, but I happen to like factor by grouping. So we're going to do this today using factoring by grouping. If you have another method that you feel more comfortable with and you get the right answer, then go for it. So when you're factoring by grouping, you have to begin by multiplying the first term by the last term. So 3 times 4 is 12. I'm looking for two numbers that multiply together to give me 12 and add up to 8. And that would be 6 and 2. So what's going to happen now is I'm going to rewrite this middle term as 6t plus 2t from my two factors, 6t and 2t. So I'm just rewriting that middle term. That's all that's going on. So I still have my 3t squared, and I still have my plus 4 out here at the end. I've just rewritten 8t as 6t plus 2t. Now here comes the part that it gets its name from, the grouping. So I'm going to group my first two together and my last two together. And then I'm going to figure out what they have in common, what their greatest common factor is. Well, 3t squared and 6t both contain a 3t. So I'm going to factor out a 3t. And remember, factoring out is basically just undistributing. So what happens, what I'm left with when I factor out that 3t is I'm left with a t and I'm left with a positive 2. And if I were to just multiply these back together, I should get what I started with. So 3t times t is 3t squared, and 3t times 2 is 6t. All right, same thing happens here. I'm going to figure out what these two have in common, what their greatest common factor is, and it would be 2. So I'm going to factor out a 2, and that leaves me with t plus 2. If I've done this correctly, I should have this same thing in parentheses. So now I've got two terms, and what they each have in common is a t plus 2. So I'm going to factor out a t plus 2, and that leaves me with these two things, 3t and positive 2. So my other set of factors is 3t plus 2. And if I want to check to make sure I did it right, which is always a good idea when you have a leading coefficient that is not 1, I'm going to take and I'm going to FOIL these back together. So t times 3t is 3t squared, and t times 2 is 2t. 2 times 3t is 6t, and 2 times 2 is 4. And then I go ahead and combine my like terms, and I get 3t squared plus 8t. I don't know why I don't get 8t. Come on, 8t. All right, let's try this again. 8t plus 4, which is what I began with. So I know that I did it right, and I know that this is my answer. Okay, let's try this one more time so you can see it again. I'm going to take my first term and multiply it by my last term. 20. I'm looking for two things that multiply together to give me a positive 20 and add up to a negative 9. And they are negative 4 and negative 5. So now I'm going to rewrite negative 9s in terms of negative 4 and negative 5. So I get 4s squared minus 4s minus 5s plus 5. Now you can write these in any order. It does not matter. It'll make your middle steps different, but you should wind up with the same thing at the end. I like to try and group mine by what makes the most sense, what looks like it will have the most in common. All right, so now I'm going to group these guys. And here we go. These two terms both contain a 4s, so I factor out a 4s, and I wind up with an s minus 1. Now, here comes the tricky part. Because my leading coefficient here is negative, I have to factor out a negative 5. When I do that, it gives me a positive s, but if I factor a negative 5 out of a positive 5, I'm left with a negative 1, because factoring is basically dividing, right? That's what I did. I did 5 divided by negative 5, and I got negative 1. All right, it's important that I do it this way because I need to get the same thing in parentheses. So now that I factor out my s minus 1, and it leaves me with a 4s minus 5. And there's my answer, which I can then go ahead and FOIL back together if I want to check and make sure that I got what I started with. All right, I would like you to attempt both of these on your own, so go ahead and hit pause, and then once you've got some answers, start the video back up again. So for this first one, you should have gotten negative 2t plus 7 and 2t plus 1. They do not have to be in that order. They can be flip-flops. And for this one, you should have gotten a 6x minus 4 and an x plus 1. Questions? See me tomorrow. You know, actually, I've just been thinking about this one some more, and I feel like we should have done it differently. I feel like we should have begun by factoring out a greatest common factor, which would be a 2, which would have left us with a 3x squared plus x minus 2. And that means that we would have actually wound up with a 2 and then a 3x minus 2 and an x plus 1. And that's a much better answer than that previous answer that we came up with. So if that's what you got the first time, then good job. All right, I'd like you to try these two also. So hit pause and come back when you've got some answers. So this one should have factored into y minus 5 squared. That didn't have a leading coefficient, so that should not have been that difficult. And this one should have factored into 3f minus 2 squared. Both of these are perfect square trinomials. And those also have a special pattern which can make your whole life a whole lot easier if you memorize them. But I don't feel like talking about it right now. You can ask me in class tomorrow if you're interested. All right, see you in class.